you guys grab. So, this foldable is a good summation of everything that we've kind of done in terms of factoring. Because remember, factoring we've been taking about a week and a half on, all right, alone, because it's just a big part of Math 1. And it's also going to be a huge part of Math 2 and Math 3. So knowing how to factor is really, really important. That's why we took so long on it. All right. So the front of your foldable is just kind of a summation of the different methods. So what factoring method would this one be? Not box, but reverse box. Remember, box is for multiplying, reverse box is for factoring. What about this one? What method's this? That's big X. Yes, sir. Yes. Grab me a pen. All right. What about this last one? What method is that? Nope. Oops. Polynomial? That's not a method. That's a name of an expression. That's grouping. So, this is grouping. Guys, stop talking. So, this is grouping. What's the other name for this method if we were using it for a trinomial? So look back at your notes if you don't remember. There's two methods that I taught you with factoring trinomials. Reverse box and what's the other one called? AC method. Good. So this is not only factoring by grouping, it can also be considered the AC method. Now, that's just kind of a review of what the different types kind of look like. Now, the inside of your foldable is kind of what's the most important. So this is a flow chart explaining that when you have any factoring problem, but they don't tell you what method to factor by, it could be multi-step, it could be just a single factor, one and done, all right? This flow chart tells you what you need to look for every time, and then it gives you a good idea of what methods to use. So first things first, starting at the top of the flow chart, the first thing that you should do for any factoring problem, this is the number one thing you got to do every time. This is always step one. You need to ask yourself, is there a GCF? All right. If there's not, you move on to the other factoring phases. But if there is, you got to factor out the GCF first. So just to review, for this example right here, all right, this expression, we're just factoring out a GCF. What do you think the GCF of this expression would be? 4 is part of it. Now, someone else tell me what's the GCF of the x's. So how many x's do x squared and x have in common? 1. So my GCF would be 4x. Now, that's my first factor technically. How do I get the second? So when I take a GCF out, how do I find that second factor? Right, we divide both of the terms by our GCF to get our second term, or second factor. So, 4 divided by 4 is 1. X squared divided by x is what? X. Negative 8 divided by 4 is negative 2. X divided by x is 1. So this would be our completely factored expression. Yes. Next to the 2? No, because these two x's here, they cancel out. Because you're dividing x divided by x. And remember, anything divided by itself is 1.
What about that fourth x then?
So the 4's go away. The 4x is your GCF. X squared divided by x. If you take 1x away from x squared, you're left with an x. So that's where we got that.
Basically, using the 4x, if you multiply it by the things in the parentheses, you should get the equation up there.
All right. So after you check for a GCF, the next thing you need to ask yourself is how many terms are you left in your bubble? All right. So whether you have a binomial, a trinomial, or a 4-term polynomial. So you ask yourself how many terms? Because more often than not, the number of terms will depend on kind of what's going on. So we learned about this yesterday. First off, if you have 2 terms, the only method that deals with factoring a 2-term polynomial or a binomial that is not GCF is difference of squares. So remember, the formula for difference of squares is if you're given 2 perfect squares and they're being subtracted from each other, it factors like this. So a plus b times a minus b. And to get your a and b, you just take the square root of both of your perfect squares. Because remember, what did I say is a perfect square? What does it mean for any value to be a perfect square? Nope. So we talked about this yesterday a lot. What does it mean for it to be a perfect square? Say it again, Manny. Elise.
Cancel each other out?
What cancels out? You're close. What cancels out? What cancels out a square? Or what undoes a square? A square root. So, in other words, a perfect square has a nice square root. So, on the board from yesterday, 1, 4, 9, 16, 25, 36, those are all perfect squares because they have nice number square roots. All right, same thing with x squared. That's a perfect square because its square root is x, which is still a nice value. All right. So with this example, so 4x squared minus 25. Oh, crud. It's called my computer hates me today. So 4x squared minus 25. First thing you got to ask yourself is, are both terms perfect squares? Yes or no? Yes. All right. Guys, shh. So, since they're perfect squares, we're going to take the square root of both terms. All right. What's the square root of 4? 2. What's the square root of x squared? The square root of x squared, x. So 4x squared, square root of 4x squared is 2x. That's how you can kind of break it apart if that part confuses you. Do the number, take the square root of the number, take the square root of the variable. All right. What's the square root of 25? That one's 5. All right. Now, once you get your a and your b values, you just put it into this formula. So basically, you write the 2 terms, one separated by a plus, one's by a minus. So your answer would be 2x plus 5, 2x minus 5. And that's your answer. Because recall from yesterday when we did algebra tiles, what was the main goal when you were doing a difference of squares? Someone who hasn't talked today. So, yesterday when we were doing difference of squares with our algebra tiles, what was the thing that you had to make sure happened? Well, it has to be a rectangle or a square in this case. Look at the binomial that we started with. What's it missing? So it has an x squared and a constant. What's missing? Gary. It's missing an x value. So remember, yesterday we wanted the x to equal 0, all right, or have 0 x's. So if we were to FOIL that expression that we just came up with, it would, our x's would end up canceling out, all right? Now, that's with 2 terms. 3 terms is what we've done a majority of our factoring with. So, factoring trinomials, whether your a value is equal to 1 or it's not equal to 1. So, starting with the easy, when a is equal to 1, meaning that you would have x squared plus bx plus c, there wouldn't be a number in front of the x squared. Whenever we factor a trinomial, what is the thing that we always start with? So we label ABC first. But after that, what do we always do? What method? Big X. So you always do big X. All right. What goes up top? Not A and B. A times C. So what's 1 times 15? 15. Again, we don't care about the variables. What goes on the bottom? So we already handled A and C. What's left over? So we already dealt with A and C. What's left over? B. So B goes on the bottom. So remember, I need 2 numbers that multiply to 15 but add to 8. What are those 2 numbers? 3 times 5. And they're both positive because the 15's positive and the 8's positive. Now, I'm going to throw an X next to the 3 and the 5. Because remember, whenever we do either reverse box or AC method, these 2 values are going to replace the 8x. All right, so I'm going to do a reverse box. So if I draw my box real quick, remember, you're using your original polynomial, but you're just replacing the b. So your x squared always goes in the top left corner. Your constant, or your 15, always goes in the rightmost corner, or bottom right. Then your 2 factors that you came up with can go in either other spot. It doesn't matter. So you could have switched the places of the 3x and the 5x. It'd still give you the same thing. Now, what times what gives you x squared? X times x. So we know this x goes here, x goes here. All right. Now, x times what gives you 3x? 3. So that's what goes above the 3x, so plus 3. Then x times what gives you 5x? 5. This will be plus 5. And thus we got our 2 factors. So it's like doing box method multiplying, but you're working, instead of working outside in, you're working inside to out. So your 2 factors are x plus 5, x plus 3. All right, same thing with this example, except take into account that this c value is negative. So if the c value is negative, what would the signs look like for our 2 factors? Positive and negative. All right, so we get negative 40 up top, 6 on the bottom. What are 2 factors of 40 that would subtract to give you 6? So if we don't know off the top of our head, let's just list some. So someone name me one set of factors for 40. 4 and 10, 1 and 40, 2 and 20. What's the other one? Not 5 and 6, but 5 and 8. Hey, you were half right. You got the 5. All right. So now, Which of those sets of factors could potentially add or subtract to give you 6? 4 and 10. Now, since it's going to subtract to give us 6, and the 6 is positive, which of the two has to be negative? The 4. So this would be negative 4 here and 10 here. And again, I'm going to throw x's after it. Now I can do my reverse box. So I got the x squared in the top left, negative 40 in the bottom right, then negative 4x and 10x. And again, it doesn't matter where you put them. So x times x gives me x squared. X times 10 would give me 10x. X times negative 4 would give me negative 4x. And then negative 4 times 10 is negative 40. So guys, I'm going through these fast because we've already done formal notes on these. This is just review. So my two factors are this, x plus 10 and x minus 4. So again, I'm going through these examples fast because you should already know the processes because we already had big formal notes on them. All right, this is just a crash refresh. Now, that's when your A value is equal to 1. But we know that's not always the case. Sometimes your A value is not equal to 1. When that happens, you have to do one of two methods. So the first method is what I see most of you guys prefer. And so it's referred to as the diamond method, but in reality, it's reverse box. It's the same thing. So remember, we always start with our big X. So label ABC, and we always start with big X. Don't forget that A times C goes on the top and B goes on the bottom. So what's A times C in this case? 6. What's my B value? 7. Now I need two factors of 6 that add to 7. What are those two factors? 6 and 1. And they're both positive. Do 3 and 4 multiply to 6? So it has to be both criteria. So it has to both multiply to 6 as well as add to 7. Now, I can do my reverse box. So again, you're using your original polynomial, but you're replacing the 7x with the 6x and the 1x. All right. So we get 2x squared in the top left, 3 in the bottom right, and then it doesn't matter where you put the 6x and the 1x. So I'm going to put them here. Now, this is where it gets a little bit tricky because you kind of got to think about it for a little bit. How do I get 2x squared? I have to multiply what times what to give me 2x squared? Not 3. So x is one of them. What's the other one? 2x. So x times 2x gives me 2x squared. Now, the x placement is not going to hurt us that much, but the 2x, we got to figure out where it goes. So the 2x can go either here or here. Where do you think it would make the most sense to put the 2x? In the green or in the yellow? Green. Why?
Because you could do 2 times 3 equals 6.
Right. Because if we put the 2x in the yellow, there's no number that we can multiply or a nice whole number that we can multiply to give us 1x. But there's a nice whole number that we can multiply at 2x to give us 6x. So you kind of have to think ahead a little bit. So I would put 2x here and x here. And then once we got our x place, the rest of it's easy. What times 2x gives you 6x? 3. So this is plus 3. What times x gives you 1x? 1. So this is plus 1. And we got our two factors. So my two factors are 2x plus 1 times x plus 3. So again, the hardest part of the reverse box when A is not equal to 1 is trying to figure out where to place your X values, because one of them is going to be a numerical number that's bigger than 1 in X, and the other one's most likely is going to be an X. And you got to figure out where they're going to go. All right. Now, the other method is our AC method. So remember, that's just a big grouping problem. So you first multiply your A times C, which they already did to give us negative 40. So if we do our big X, negative 40 goes on top, and then negative 3 goes on the bottom. Now, since the 40 is negative, what signs do the two factors have to have? Negative and positive. So one of them has to be negative. Now, we already listed some factors of 40 above. Which two factors could potentially subtract to give you negative 3?
What did you mistakenly say?
8 and 5. Now, guys. Now, which one has to be the negative one? 8, because we want it to be negative 3. So the 8's negative, the 5's positive, and I'm going to throw an X after it. So what that means is that we're going to take these two factors and split the negative 3x apart. So if I rewrote this, it's 2x squared minus 8x plus 5x minus 20. Now, since we have a 4-term polynomial, we can go into grouping. So we can go into grouping now. So I'm going to rewrite it up here. So 2x squared minus 8x plus 5x minus 40. So remember, your first step with grouping is you split the first two terms and the last two terms into two groups. So your first two terms are a group, your last two terms are a group. From there, it's a big GCF problem. So what would the GCF be of your first group? 2x. All right. So we're doing divide by 2x. I get 2x times x minus 4. All right. What would the GCF be of your second group? Not 5x, but nope. Just 5. Why is it not 5x, Embry?
Because the negative 40 doesn't have like an X.
Right, because the 40 doesn't have an x. So it can't be 5x because both terms have to have an x. Since it doesn't, it's just 5. So I'm going to divide both terms by 5. I get 5 times x minus 4. Now, what did I say has to happen in order for us to know that we did the grouping correctly? The bubbles have to match. So x minus 4, they match, so we know we did it correctly. Now, remember, the last step is to take your two GCFs and combine them into one bubble. So this will be 2x plus 5. And then you take one of your common binomials or common bubbles and bring that down as well, x minus 4. It's almost like you're factoring out that binomial. And this would be your answer factored. So it doesn't matter which method you do for when A is not equal to 1. It's whichever one you're most comfortable with. If you like grouping better, do that. If you like reverse box better, do that. I don't care. All right, it's whatever you're most comfortable with. Now, the last part is if you have 4 terms. And if you have 4 terms, you're flat out grouping. 4 terms, automatic grouping. All right. So if you have 4 terms, you're automatically grouping. So we're just going to go through the same process that we just went through. So split your polynomial into groups of 2 terms. So here's my first group. Here's my second group. Oh, and make sure to include the sign in front of the third term of the last group. Now, we can then find the GCFs. What do you think my GCF would be for the first group? So let's look at it this way. Is there a GCF between 3 and 4 besides 1? No. What about the x's? How many common x's is there between x cubed and x squared? 2. So our GCF is what? 1x squared or just x squared? Good. So we divide both terms by x squared. I would get 3x plus 4. All right, that's our first group. What about our second group? What's the GCF of my second group? Just 2. So I divide both terms by 2. 2 on the outside, 3x plus 4. Now, do my bubbles match? Yes, so we know we did it right. So I'm going to bring down my 2 GCFs into one bubble. So it'd be x squared plus 2. And bring down one of my common binomials, which is 3x plus 4. And thus we are factored. Now, that was just a crash course in all the methods that we already learned. But that's not what today's lesson is on. Today's lesson is on multi-step factoring. So in your journal, either on the left side of the page or on a new page in your journal, we're going to do some handwritten examples. All right? So we're going to do some handwritten examples. So everyone needs to write these examples down. They are part of your notes, hence also part of your journal grade. So the first example we're going to do is 8 minus 2x to the 4th. There's some on the shelf over there. Now, I would keep your flow chart out so you can kind of tell what you're going to do first, next, whatever. So, let's go with Manny. What's the first step that we always have to do when we factor anything? What's it say our flow chart we have to do first? We have to always find a what? Or try to find a what? A GCF. Yes. Yeah. So, first thing we got to look for is a GCF. You always start by looking for a GCF. Sometimes you have one, sometimes you don't. Do I have one in this case? Yes. What is it? 2. So I'm going to factor out that GCF first. So I'm going to divide both terms by 2. I get 2 times 4 minus x to the 4th. Now, once you factor out the GCF, you're looking at what's left in the parentheses. How many terms is that? 2. So let's go with Cheyenne. If there's a 2 terms, what factoring strategy are we most likely going to be using? So if we have 2 terms, what factoring strategy are we most likely going to use? Difference of squares. So we're going to be using difference of squares. All right. So just a reminder, difference of squares is a plus b, a minus b when we factor. Now, Are both those two terms perfect squares? That's the first thing we got to ask.
Yes.
Yes, they are. So I'm going to take the square root of both. Square root of 4 is what? 2. What's the square root of x to the 4th? X squared. Remember, any even exponent is a perfect square. To get its square root, you just divide the exponent by 2. That's your new exponent. All right. So, what would my two factors be, 8 and a? So I got my a and my b value. So now I need to put it back into this formula. So what would my two new factors be? So a plus b, what's my a, what are my b values?
2 plus x squared.
Okay, that's the first. What's the second one?
2 minus x squared.
There you go. So we get a factor to 2 plus x squared, 2 minus x squared. Now, I'm not done. That's not my final answer. What do I have to bring down? The GCF of 2. So now this is my final answer. Because even though we have an x squared, we cannot do another difference of squares because 2 is not a perfect square. All right, so we know we're done because we don't have all perfect squares. So that was example 1. 5. So example 2 is 81x to the 8th minus 1. Yeah. When Chris gets back. So 81x to the 8th minus 1. First things first, we got to ask ourselves, is there a GCF? Is there a GCF? No. So since there's no GCF, we move on to the next step. What strategy do you think I'm going to use based off of how many terms we have Foster? So what strategy am I going to use based off the number of terms that I have? So it's a binomial, so that means we have to use what? What does your flowchart say for 2 terms? Y'all quit. Difference of squares. So, again, this is a difference of squares problem. Because 81x to the 8th is a perfect square and 1 is a perfect square. So we're going to take the square root of both. 81x to the 8th. All right, what's the square root of 81? 9. What's the square root of x to the 8th? X to the 4th. If you divide the 8 by 2, that gives you 4, so that's your new exponent. That's your a value. Your b value, what's the square root of 1? 1. So, given our two a and b factors and the formula for difference of squares, Chloe, what is my factored form for this? 9x to the 4th plus, because these two are together, plus 1. There you go. Good. Now, do we think that we're done? No. Why? Yeah, we still have another difference of squares. So we got to do another difference of squares. Now, why can I not factor this one anymore? Oh my gosh. So why can I not factor the 9x to the 4th plus 1 anymore? We talked about this yesterday.
So it's only like a subtraction part of
Right. So it's in the name. Difference of squares. Difference refers to what operation? Subtraction. This is addition. We cannot do a difference of squares with addition. All right, it has to be subtracting. Otherwise, it's not a difference of squares. So 9x to the fourth plus 1 cannot be factored anymore. Yes. No, it flips over like a tablet. Now, so I'm going to do another difference of squares. So take the square root of both of these again. What's the square root of 9? What's the square root of x to the fourth? X squared. And then the square root of 1 is 1. So let's go with the least. What are my two factors now? 3x squared plus 1 and? Good. Now, that is not my answer quite yet. What am I missing? I'm not missing a negative. What am I missing? The what?
The one in front of both of those factors.
Right. The first factor from the top. It's not fully factored unless we rewrite that factor. So 9x to the fourth plus 1. If there's ever something that you had to refactor or you have to factor again, but another part you don't have to factor again, make sure you bring down the part that you don't. So this would be our answer. Yeah, final answer. All right. Number 3. We got 4x squared minus 64x plus 252. Now, that problem looks ugly because the numbers are huge. However, and let me ask you guys this, your first instinct would be to do AC method or big X. Don't do that just yet. Because what do you always have to look for first? A GCF. Do you think there's a GCF? There is. Shot in the dark, what do you think it is? 4. It is 4. Yeah. Because there's no x's connected to it because not every term has an x. That 252 is xless. So we're dividing. So we're dividing all these by 4. So I have 4 on the outside. X squared minus 16x plus 63. Now I'm left with a trinomial in my bubble. So what's my next move? Let's go with Caleb. If I have a trinomial and I'm factoring a trinomial, what do I always start with? Labeling A, B, C. So A, B, and C. Then what do I do, Caleb? Big X. Good. So I have 63 up top, negative 16 on the bottom. I need two terms that multiply to 63, add to negative 16. Now, since it's multiplying to a positive but adding to a negative, what are my two factors? They're both negative. Negative times a negative is a positive, and a negative plus a negative is a negative. Now, can anyone think of two terms that multiply to 63, add to negative 16? Come on, guys, that's basic multiplication tables. 9 and 7, good. So, negative 9 and negative 7. So I'm going to throw an X on the end of them so I can do my reverse box. So I have X squared in the top left, 63 in the bottom right, and then negative 9X and negative 7X in the other two corners. So we know that X times X gives us X squared. So that's always a good place to start. Now, What times x gives us negative 9x? Negative 9, so we're going to put a minus 9 up here. What times x gives us negative 7x? Negative 7. And then to check ourselves, negative 7 times negative 9 is positive 63. So we know we did the correct thing. So here are my two factors. So I have x minus 9 times x minus 7. And what am I missing from my final answer? The GCF of 4. So I'm going to bring that down. Yep, always got to bring down that GCF. And that's my answer. So guys, all these examples are basically all the different types of multi-step factoring that you'll see. So we're going to do 2 more. All right. Trust me, you want me to do these examples. They'll help you out. Just hint, hint, wink, wink. Trust me, you want me to do these examples with you. Hint, hint, wink, wink. All right. So, example 4. We got 5x cubed minus 5x squared minus 100x. Doesn't really look like one that we've done before. However, what do we always look for? GCF. Is there a GCF? Yes. What do you think it is? 5x. Good, Sanaya. So, every term now has at least one x. So not only do we have a numerical GCF, we also have a variable GCF. All right. So we're going to divide all 3 terms by 5x. So I have 5x on the outside. So I get x squared minus x minus, what's 100 divided by 5? Nope. 20. Good. 25 is 100 divided by 4. All right. So, our bubble we have left is a trinomial, so we go straight into big X. What goes on top? A times C or negative 20. What goes on the bottom? Nope. Not just 1, but negative 1. So remember, if you just see an X, there's an unspoken 1 in front of it. We only care about the number. So we need 2 values or factors of negative 20 that add to negative 1. 4 and 5 would most likely work. Now, since we're multiplying to a negative number, one of them has to be negative. Which one? The 5, because we're adding to a negative. So I'm going to throw my X's on and then make my reverse box. All right, so I got the x squared in the top left, negative 20 in the bottom right. And then you can place the negative 5x and the 4x in either one of the 2 boxes. It doesn't matter. Again, x times x gives you x squared. All right, that's always, if you have x squared in the top left corner, like just flat out x squared, you can always start with x times x. So, x times what gives you negative 5x? Negative 5. X times what gives you 4x? 4. So these are my 2 factors. So I have x minus 5 times x plus 4. And then what am I missing for my final answer? The 5x. So we bring down that 5x. So guys, the common mistake that I see with this is you forget to bring down the GCF. Always bring down that GCF. Circle it if you need to remember it. All right? Or highlight it, whatever. Whatever you need to do to remember to bring that sucker down. Because the GCF is important in terms of factoring. It's not fully factored without that GCF. All right? Last one. So, number 5. We have 50x to the 10th minus 18x squared. So, very first thing we got to do is what? GCF. Is there one? Yeah, there is. 2 is part of it. 50 and 18 both have 2 in common. What about the x's? How many do they both have in common? X squared. Good. So I'm going to divide both by 2x squared. So I'm going to put the 2x squared out front. What's 50 divided by 2? 25. Now, think about this carefully. X to the 10th divided by x squared. If you took 2 x's away from x to the 10th, how many are you left with? 8. So this is x to the 8th. Minus, the x squareds will cancel, but 18 divided by 2 is 9. Now, we have a binomial left in the bubble. So what method do you think we're going to use next? Difference of squares. Do I have 2 perfect squares as my term? Yes. So we can take the square root of both. So, square root of 25 is 5. Square root of x to the 8th is x to the 4th. Remember, just divide that 8 by 2. That gives you your new exponent. Square root of 9 is 3. So this would be 5x to the 4th plus 3 times 5x to the 4th minus 3. And then I need to do what to finish it up? Bring down my GCF. Now, do you think we're going to do another difference of squares here? Are you sure? No. Why not?
Because we can't, there's no quick difference of 5.
5 and 3 are not perfect squares, so we're done. All right. All right. So, if you took the time to write down those examples, you have the first 5 answers to your Delta Math. All right. So, you can literally, all the single problems on your Delta Math, you got the answers already. So you can just type them in. So, you do have 5 more problems on that Delta Math to do on your own. So, get to work.